In this video, we will be discussing about combinatorics. In this topic, there are 3 subtopics that we have to cover, which are permutations, combination, and variation. Let's start with permutation. Let's jump right in. Let's get into permutations. Starting with the definition, if we arrange all the existing elements in a variety of ways, we call it permutation. Now let's look at an example in which there are 4 different colored circles. How many possible arrangements of these 4 colored circles exist? That means we can swap their positions. Let's start with the first circle on the left. This circle can be blue, red, orange, or green, so 4 possibilities. Let's go through one scenario together in which the first circle is blue. Now that means, coming to the second circle, it can only be red, orange, or green, since blue is already taken. Let's say it is red. That means the third circle can only be orange or green. If we say that it is orange, the last circle can and only will be green. Now this is one possible arrangement out of many. So how many arrangements are there? So we see that there are 4 possibilities for the first circle, 3 for the second 2, for the third, and 1 for the last. So in order to find all the possible arrangements, we have to multiply 4, 3, 2, and 1. So we have found out that the formula is the multiplication of 4, 3, 2, and 1. Now, how do I form a general formula? What is the multiplication of 4, 3, 2, and 1? It is actually 4 factorial, and 4 is the number of elements. So a general formula would be n factorial, if n was the number of elements. To summarize it, n factorial is the formula for finding all possibilities in a permutation. Thank you very much for watching this short video. Hello everybody. Welcome to the second part of Combinatorics. In this video, we are going to talk about permutation of k elements in n elements. I believe I have called this variation in the last video, but that's not very common. Okay, let's start with the definition. Here we take a few of the given elements, in which the order of the items is important. Here, there are 2 ways we can further divide this: without repetition and with repetition. It will get easier to understand once we jump into the examples. Let's start with without repetition.
Okay, let's jump right into an easy-to-understand example. In the case of no repetitions, in a permutation of k elements in n elements, where the order matters. I will clearly explain what order and repetition means after this example. Let's take a look at 5 different colored squares. Let's say that this is the best square competition, and we want to give the prizes from the first best square to the 5th best square, and we rank the squares like this. Now, the winners are of course only the top 3 squares. Now the question is, how many possible winners are there? The winners in this case are blue, red, and green, but it could have been orange and yellow too. Let's look at all the possibilities. To understand this part of the video better, you should check out the last video on permutations, which is in the link in the description. Now for the first winner, could be blue, red, green, orange, or yellow. So 5 possibilities. If we say blue won the first one, the second winner could be red, green, orange, or yellow, since blue is taken if the second winner is red. The third winner can only be either green, orange, or yellow. The 4th and 5th don't matter for us. This fits the definition since we are only taking few of the elements. That means that the number of possibilities of the winners is the multiplication of 5, 4, and 3. So, what do I mean when I say that the order does matter? Let's look at the 3 winners again. We can see that they are in a certain sequence or a certain order. Now let's look at another order of the three winners. Why is this order different? It's because the square that came first has changed. We consider this as a different possibility. So when I say that the order is important, that means that I consider these two orders as different possibilities. But you might say, hey, wasn't that obvious? Of course, we have to consider different orders as different possibilities. You are right, but it changes when we come to combinations. More on that in another video. Now, before we discuss about the second part of permutations with repetition, and before we go through what repetition means, let's find a general formula for permutation of k elements in n elements without repetition. So what was our result in the end? It was the multiplication of 5, 4, and 3. But that looks an awful lot like 5 factorial. But something is missing. It's the 2 multiplied by 1 in the end that are missing. That is basically 2 factorial. So that means that the multiplication of 5, 4, and 3 is 5 factorial divided by 2 factorial. Now, let's make a general formula. 5 is n, the total number of elements, and k is 3, the number of elements chosen. The 2 factorial is basically n minus k. So that means that the formula is n factorial divided by n minus k factorial. So, now coming to permutations with repetitions, that basically means that one color can appear more than one time. All the winners can be red. I believe that this is the easiest out of all, because that basically means that the first square can be all 5 colors, so can the second square and the third square. So the formula is the multiplication of 5 3 times. That is basically 5 to the power of 3. The general formula is then basically n to the power of k. We are going to talk about combinations without repetitions, one of the final episodes in this Combinatorics series. Let's start with the definition of a combination. A combination is when we arrange a few of the elements and the order doesn't matter. It is basically same as the permutations with repetition, just that the order doesn't matter. That basically means these 2 rows of squares are the same. Now let's see an example with 3 squares. Since the order doesn't matter, all the squares can be the same color. So if I were to pick a combination of 2 of the squares, what are all the possibilities? Let's first see all the possibilities of one of the 2 squares, which is 3. The first square can be one of these 3 squares. The second square can only be one of the remaining 2 squares, since the one of the 3 squares is already the first square. At this point, you might think we should multiply 3 and 2 together. You are right, but if we swap the position of the squares, that should not be considered as another possibility, because the order doesn't matter. Now these 2 squares should be considered one possibility, even after being swapped around, since that doesn't make a difference. So how do we do that? It is just 3 times 2, just like in permutations, divided by the number of possible arrangements of the 2 squares, which is 2 factorial. Now, coming to the formula, if you haven't noticed already, it is basically just the permutation without repetition formula divided by k factorial, which was 2 in our case. That is the formula. I hope you all have enjoyed this series and learnt something. See you in the next one.